ambiguous grammar. A grammar G is said to be ambiguous grammar if for a string X belonging to the language of the grammar L of G and G has two or more leftmost derivation or two or more rightmost derivation. So what does it mean? If you have a grammar G for any string belonging to the language generated by the grammar, if we can derive this X using G with two or more leftmost derivation or two or more rightmost derivation, then we call that grammar as ambiguous grammar. Now let me explain this with the help of an example. We will take this grammar S goes to AS or capital AS or A and A goes to capital AS or A. Now we'll take an example string AAA. Now if we were able to derive this AAA using two leftmost derivation by using the productions of this grammar given, then we say the given grammar G is ambiguous grammar. So let me try to derive this X using leftmost derivation. So I'll start with AS, and for this S, since you have only one non-terminal, no problem. So for this S, I'm deriving as AS. Since S goes to AS is a production in G. Now you have two non-terminal. Since you are deriving using leftmost non-terminal, we'll try to replace this A. We'll use the production A goes to A, and we can replace this with A with small a. Now you have only one non-terminal, so we are deriving the string using leftmost non-terminal. So we have S goes to A, capital A, and then using leftmost derivation A, since A goes to A is a production in G. So starting from S, applying the grammar G one or more times using leftmost derivation, we were able to derive AAA. Now if we were able to give another leftmost derivation for the same grammar, using the same grammar and derive this AAA, so I'm going to use starting from S. For first leftmost derivation I have used this production. Now S goes to AS. Let me start with S goes to AS. Now since leftmost derivation, we'll be replacing this A with another AS. Since you have a production A goes to AS in G. Now next leftmost derivation, this A you replace with A. Since A goes to A is a production in G. Next leftmost derivation, you have two S. First S you have to replace. So replace this with A. Since S goes to A is a production. Now you have again two non-terminals. Replace the leftmost non-terminal. Replace A with A. Since A has a production, A goes to A is a production. Now only one S left out. So replace that S with A. Since S goes to A is a production. And then again this one A. Since A goes to A is a production. Now here again, starting from S, applying the grammar G one or more times using leftmost derivation, we were able to derive AAA. So for this grammar G, using the given set of production, we were able to give for this particular string X is equal to AAA, we were able to give two leftmost derivation. So there exist two leftmost derivation for x is equal to a using grammar G. So now if this exists, then it is called as, then G is called ambiguous grammar. Ambiguous grammar. Now we will take one more example. And we will check whether grammar is ambiguous or not. Okay. Take down the second problem. S goes to 0y or 0 1. Y goes to xy 1 or 1. X goes to, one second, let me rewrite it correctly, xy 1 or 1. X goes to 0 xy or 0. Now the string you are going to consider is 000 followed by 111. Now we'll try to give leftmost derivation. So you have to start with OY. Now for this one, we can use 0xy 1. Okay, again leftmost. So you have to replace this x. Let me replace this x with 0. Since you have a production, y goes to xy1. Here, since you have a production, x goes to 0. Now you have this y, so you make it x, y, 1 and 1. Since you have a production, y goes to xy1. Now 0, 0, this x you replace with 0. Since you have a production, x goes to 0, y 1, 1. Again using leftmost derivation, 0, 0, 0, 1, 1, 1. Since you have a production, y goes to 1. So we were able to give one leftmost derivation. So starting from S, applying the grammar G one or more times using leftmost derivation, we were able to give 0, 0, 0, 1, 1, 1. Now we'll try and derive another leftmost derivation. So we have to start only with y. Again for this y, we have to use only this. Y goes to xy1, because if we use this production y goes to 1, it will be a terminal. So we can't use, so we are going to use this one. Now for this x, S goes to LMD. Instead of 0, we can use this production 0 xy. So 0, again a 0 xy for this x, again y1. Now if we replace like this, since you have a production, x goes to 0 xy. I am replacing this x with 0 xy. Now again leftmost derivation 0, 0, this x, we can use the production x goes to 0 and replace with 0, 0. And again leftmost derivation 0, 0, 0. Since you have a production y goes to 1, you replace this y with 1. Again leftmost non-terminal. Every time we have to replace only the leftmost non-terminal. We are trying to replace only the leftmost non-terminal. Still we were able to derive 0, 0, 0, 1, 1, 1. So starting from S, applying the grammar G one or more times. Again, using leftmost derivation, we were able to derive 0, 0, 0, 1, 1, 1. So this x can be derived using using this grammar G with leftmost derivation. Two leftmost derivation. So this grammar G is ambiguous grammar. Now I'll give you two more problems. You can check whether the given grammar is ambiguous grammar or not. You can practice for these problems. So the grammar is S goes to small a, or small a, small b, capital S, small b, or a, b. A goes to AS or A, B. And your string is AB, AB, ABB. Check whether the above grammar is ambiguous or not. Now you take one more example. S goes to A or SA or B. A or SA or BSS or SSB or SBS. Now the given input string is AA, BA, BA, BAA. Question is, check whether the grammar is ambiguous or not. Practice both these problems to get a clear idea of what is ambiguous grammar.